introduction today. You guys want to get up and dance, though, for a little bit?
Yeah.
Here we are.
Extra credit again.
Oh, hi. Hi.
All right. Here we go. Okay, you guys. Let's see. Today, they're so excited about doing the math today. Today we're doing functions. What do you think about that? Oh, all right. Yeah, it's a good day. All right. Here we go. So we got to go quick. We should try and do warp speed lesson today and see what happens. Okay, ready? So, do what?
You should just like write everything down, like copy down homework.
Bam. Yeah.
That's hyperspeed right there.
Hyperspeed, I know. I could. I actually used to teach at warp speed, believe it or not. I could do it.
Do
I
it.
don't want to leave you all behind. That's not okay.
And then just write everything down and explain it to us as you go.
Warp speed is on
Okay.
6, don't worry.
All right, here we go. Yeah.
The example questions should be homework questions, so that we don't have to do as.
I will think about that.
Yeah.
So the suggestion was that the example questions should be homework questions. I will think about that. All right, you guys ready? Here we go. A function. Clap if you have heard the word function before. Okay, good. All right, so for the purposes of what we're doing today, a function is, let's see, a function is a relation. Let's see, we can put this together on the fly. A relation or an equation, and we have people coming up. They love the math so much that they are coming up to the screen to see it. Okay, so you guys feel free to move around anywhere that you would like to as we go through notes here, okay? Okay, so it's a relation or an equation when graphed, let's see, when graphed, there are no 2 points, or there are no points directly on top of each other. Okay. So we're going to go through some specific examples of this, so you guys can see exactly what that would look like. The way that we're going to, one of the ways that we're going to figure out whether something is a function or not is by what's called the vertical line test. Clap if you've heard the vertical line test before. Okay, so that's some of us. Vertical line test. All right. Oh, I just thought of something we should do. What would you guys think about doing the wave after if we get examples right? We should practice the wave, and then we can do it after we do some examples. What would you think about that? We got to spice it up here. I think the whole game show thing is losing its oomph. All right, that's it. We're doing the wave today a couple times, all right? You guys want to practice right now? Yeah? Okay. We are going to practice really quick.
Starting this way.
All right. I'm going to pause it. We're going to practice our wave, and then we'll come back. I'm going to leave you all in suspense about what the vertical line test is. Everybody go, ooh. Ooh. Okay. Okay. We just practiced the wave. You guys ready to show your wave skills?
Yeah. Sure.
Do you want to wait till the example?
Yeah.
What do you think? Let's wait. Okay. So the vertical line test, here's what we're going to do. Everybody should be, they're so excited about the math, they can't stop talking. Stop talking. Okay. The vertical line test. So here's how we do this. We're going to, once we graph, I actually want you guys to not graph all of these. I want you to get in the habit of trying to graph in your head, okay? Sounds kind of funky, but I'll show you. It's pretty easy. Okay, so if you were to draw, I'm going to do it a little differently this year. Draw a line, a vertical line. So remember, vertical is this way. Let's draw a let me put that in here. Vertical line in any location in the graph. Yeah, if you draw, so I'm about to finish. So if you draw a vertical line at any location in the graph, remember vertical is up and down, and you have 2 or any points directly on top of each other, you do not have a function. So again, if you draw a vertical line in any location along the graph and there are points directly on top of each other, then you do not have a function. So if you draw a vertical line in any location in the graph, and there are points on top of each other. Okay, let's do this in a different color. Then, we're going to refer back to this quite a bit today. Then you do not have a function. Okay. So, you guys tell me, if we have 2 points on top of each other, do we have a function?
No.
Where is the enthusiasm in this group
No.
today?
We do not have a function.
Okay, we do not. Good. All right, so last thing that we're going to do before we jump into our examples is function notation. Function notation. Ooh. So function notation is f parentheses x. That is function notation. We all have seen this before in Algebra 1, but I am here to demystify it for you, okay? So, f of x and y are interchangeable for our purposes right now. They mean the same thing, okay? So, we just spent a bunch of time graphing lines. So, if I asked you all to graph the line y equals 2x plus 5, clap if you could tell me the first point that we graph in the line y equals 2x plus 5. Clap if you can graph the first point. Oh, okay, that's good. They were all raising their hands at first. Okay, and then from that, so the first point is what? We do what? Up 5. And then from there we do what? Up 2 and over 1. Okay, so guess what? If I write this up on the board, f of x equals 2x plus 5, you would do it exactly the same way. Those two mean exactly the same thing. Okay? F parentheses x and y, same thing. All right? So, we're going to go through, we're going to graph one of these first, and then, again, as we graph it, I want you all to be thinking about how you would graph it in your head. Okay? So, here we go. Okay, so, which is a function? So which of these is a function? And we are going to start out with a set of points. Okay. Let me get my clipboard over here. Okay. So the first set of points we have, 9, 0, 3, 8. We've done this before. We did this in the last homework assignment. 5, 8, 9, negative 1. So I'm going to show you a shortcut, but I'm not going to show you the shortcut first. I want you all to know where the shortcut comes from. 9, negative 1, yeah. All right, so again, we're not going to graph these. Actually, what I'm doing in my head as I write these points down is I'm visualizing how would I graph the point 9, 0. Okay, I would go do this. Okay, so I'm actually drawing this picture in my head. Okay, I want you guys to get into the same habit. 7, 8, 9. My cold is still holding on for dear life. So my voice goes in and out every now and then. Okay, so here we go. Who can tell me how I would graph the point 9, 0? The point 9, 0, how is that graphed? We all better know that. Okay, Michael. Okay, if it's positive 9, what's that? That's good. Right 9 and then where from there? And then nowhere. Perfect. Everybody give Michael a round of applause. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay, I'm going to draw huge dots on here so you guys can see the point that I'm trying to make. All right, so we did 9, 0. All right, who can tell me how to graph the point 3, 8? How do I graph the point 3, 8? Desi. Okay. 3, 4, 5, 6, 7. Okay, there's 3, 8. Everybody make some noise for Desi. There we go. That's easier. Yeah. You can stomp if you want. Stomp. Stomp. Cheer. I should get one of those. Oh, that would be fun if we had one of those bullhorn, megaphone things. Then we could pass it around and you guys could talk in those. Wouldn't that be fun? Okay. 5, 8. Who can tell me how to graph the point 5, 8? How do I graph the point 5, 8? Olivia. 5, good. To the right 5 and up 8. There's 5, 8. And then the last one is 9, -1. Who can tell me how to graph the point 9, -1? Rebecca. Okay. 8, 9, down 1. Okay, so this is where that vertical line test comes in. Does anybody see, if I were to draw vertical, up and down, a vertical line anywhere on this graph, are there 2 points or any points that are directly on top of each other?
Yes.
Where? Who can tell me where those 2 points are? Gustav. Perfect. Clap or make noise if you agree with Gustav. Good. Right here. So back to our vertical line test definition. Do we have a function or no if there are points on top of each other?
No.
No, we do not. Okay. Easy? Yes? Yes, good. Okay. Now, what I want you guys to be doing is figuring out or trying to visualize graphing these points in your head. Does anybody think, if we didn't have the graph here, is there a shortcut? Is there a way that we could figure out whether it doesn't work just by looking at the coordinates? Okay, so we have a lot of people with their hands up. Let me call on Zach.
The x-intercept.
The x-intercept. What do you mean by the x-intercept?
If they both have if they have the same x-intercept, then they're going to be in the same line.
Good. So if they have the same x-coordinate but different y-coordinates, is that, so make noise if that's what you were thinking too. X-intercept is a little different. X-coordinate is good.
Okay,
All right.
edit that.
It's okay. It's all right. Okay. Questions? All right, here we go. Next set of points, we will do, let's see. Whoops, that's a 0, 1. And we'll do 2, -5. We'll do 4, 6, and we'll do 7, 9. I don't want you to graph this. Nobody graph, okay? I want you all to tell me without graphing. Again, you're visually drawing a graph in your head. 0, 1, 2, -5, 4, 6, 7, 9. Okay. Here's what I want to do. Clap if you think that this is not a function. Clap if you think this is a function. Okay. Who can explain to me why this is a function? Remember, we're doing points as we go through here. Samantha? Good. None overlap vertically and none of the x-coordinates are the same. Give Samantha a round of applause. And you ready to do the wave?
All right.
Here we go. Ready? Let's see. We're going to do our wave now. Okay. Ooh. Hang. All right. Make noise while you're doing it. Go ahead. Okay, go back, go back. All right. My camera skills need some work. That's okay. All right. Good job, you guys. All right, here we go. Let's move on. Whoops. There you go. All right. Now, we're going to do super speed graphs on this next round, and then I'm going to ask for people to come up, for contestants. We're going to go really fast, really fast here. I don't want to draw any really precise graphs on these, okay? So you're literally drawing the x and y coordinates and then putting a really quick sketch on there. You, again, you're telling me whether this is or is not a function. Okay? Again, you're just telling me whether this is or is not a function. So, what are we all, I hope we're all visualizing something in our head or thinking about a specific test that we can use to figure out if it's a function or not. Are we?
Yes.
Yes? Can somebody tell me what test that is and what I should be, where my brain should be going right now? Let's see, Rebecca? Okay, good. Make noise if you agree with Rebecca, the vertical test. Okay, so can someone tell me whether this is or is not a function? Olivia?
This is a function.
Good. It is. Why?
Because none of the coordinates overlap and they don't have like parallel pairs, so there's nothing like underneath.
Excellent. None of the points overlap. None are on top of each other. There are no overlapping things. All right. Everybody give Olivia a round of applause. Now. All right. I'm about to put 4 more examples up here. 4 more. I'm going to need 4 contestants, okay? So, here's one of them. It looks like this. Okay, so I want you guys to be thinking as I draw these, whether they are or are not, and how you would explain to somebody whether they are or are not. Okay, so there's the last 2. Yep. Okay, so we got one up there. So, let's see if we have something like this. Or, let's see, something like this. And the last one. Okay. So, oops, hang on, my screen's about to die. Right. Okay. So, I'm going to need some contestants. Everybody send us off to break. Okay, go back, go back. We lost it. Okay, we are back. Contestants, we have 4 of them. Everybody come up. Come up. Who's doing the next 4 problems? Come on up. Do them one at a time. We're going to start our music. You guys are just putting yes or no. Where's our 4th contestant? Hero, get up here.
Here we go. Yeah.
Do the third one.
Here we go.
Who's doing what? You're doing the third one.
You're doing the 3rd one. Jiro's doing the 4th one. He's doing the 2nd one. Okay, everybody clap if you agree with Aiden. Yay, Aiden. Thank you, Aiden. All right, Brandon. With the backward sunglasses. Okay, go for it. Yes, they are. Yay, clap if you agree with Brandon. All right. All right, good. Everybody give Tyler a round of applause.
1, 2, 3. Because if we didn't have math, they could.
Everybody give Tyler a round of applause.
Oh, I do.
All right, Jiro's doing the last one.
The doctors and the lawyers counting down like 1, 2, 3, 4. We can hear it on the beat and either read it on the score. So they waste of time. What are they doing it for? So they ain't gonna end up with
Okay, give Jiro a round of applause. Give Jiro a round of applause. Okay. That would be an no. That's a no. Okay. How are we doing on questions? Good. Cool. Let's move on. Please, yes, let's move on. Okay, we only have 2 more types of problems. You want to try warp speed? Want me to talk fast for this period? Like really, really fast? Yeah. Okay, here we go. Everybody zip it! Zip it. We are back. All right. Find the indicated function values. Super easy. No overcomplicating. No overcomplicating. Function values. So we are given f of x equals x squared minus 5. Find the indicated function values. We want to find f of 1. We want to find f of negative 3. We want to find f of 0. And we want to find f of a. So again, f of x, I'm sure you all can see, equals x squared minus 5. And we're finding we do not need a lot of room here, you guys. Don't worry about leaving a bunch of room. Okay, so going from f of x equals x squared minus 5. If I'm just looking at the f of x and f of 1, what was the only thing that changed from here, the top, to the next step? The x changed to a what? A 1. So what do we think the x should change to on the other side of the equal sign? A 1. So you're just replacing it with the same thing. All right, so 1 squared. Everybody yell as loud as you can. 1 squared.
1.
Okay, 1 minus 5.
Negative 4.
Negative 4. Okay, good. We're done with that one. Don't overcomplicate. Okay, who can tell me what I plug in next? What is the next one? We're finding f of negative 3. Seriously, you guys, yell as loud as you can. 4th period did pretty well. They kind of blew you out of the water. All right, so negative 3 squared is how much?
9.
That is sad. Okay, yell as loud as you possibly can. Negative 3 squared is?
9.
9 minus 5 is?
4. 13.
9 minus 5 is? 4. There we go. Okay. Ready? good. Cool. Last one, f of a. We are literally, don't overcomplicate, plugging in an a. What is a to the second power?
A squared.
That was like mega slow-mo. A squared. Oh, you guys are funny. Okay, questions? Show me where we are. Easy, medium, hard. Easy, medium, hard. Okay, questions? Questions? Okay. Last. So, are you all ready? Are you all ready? We are about to do some pre-calculus. It's pre-calculus that I've been getting a lot of complaints about from pre-calculus students. You ready? You guys are all going to blow them out of the water. Here we go. What is the domain for the following functions? What is the domain for the following functions? I'm actually going to show you guys how easy this is. I just think you guys maybe like to complain just for the sake of complaining.
Absolutely.
That's good. At least we can own up to it. Okay.
Lower class charter kids have a tendency to be too scared of things that are incredibly easy.
It could be. It could be. Okay, here we go.
Like AA, which is
Stop. Oh my God. Do not even talk about that right now.
All right. We have a debate going on in class right now. It's actually a mathematical debate. That's how much they love math. All right, here we go.
Right?
Okay. Are you all ready to see how easy this is? So you can go tell the pre-calculus students that this is way easy and they need to not complain about it? Oh. Okay. Domain. Here's what we're doing. We've done this before, actually. If there is a denominator in your equation somewhere, and the denominator has an x, in this case we have two separate pieces of the denominator, we are going to set each of them equal to 0 and solve. How do I solve x minus 1 equals 0 for x? I what? Add what? So x equals 1. And how about this one? Subtract 3. X equals negative 3. That's as complicated as it gets, okay? The domain is that x can, this is the part I think that maybe they get confused on. X cannot equal 1 and x cannot equal 3. So that's the only thing that changes. You do everything the same way we did before. Now, does anybody have any idea why x cannot equal 1 and why x cannot equal negative 3? Thane?
Because when you're involving those in the equation, that means you're putting that much above it, so it would not equal the same thing if you're adding on to it or subtracting from it.
Okay. Okay. Lorenzo?
And also, if you plug them in, it's going to equal 0.
Okay, good. If you plug in 1 into here, what's 1 minus 1? 0. Can we have 0 on the bottom of a fraction?
No.
No. Same thing here. Negative 3. Negative 3 plus 3 is 0. Can we have 0 on the bottom of a fraction?
No.
Nope. If you don't believe me, how many people have calculators today? Get them out. Everybody get out your calculators. Get them out. Guys ready? I'm about to tell you to divide something. Really easy. Ready? 7 divided by 0. Yell out what the answer is.
0.
On the calculator.
Divided by 0.
Mine says error.
Mine says error. Good. Okay, try this. 25 divided by 0. 25 divided by 0.
I got error.
Error. Okay. So, the moral of this story is you cannot have 0 on the bottom of a fraction. So, what you're saying is you're solving each of these little pieces for x and saying that it cannot equal those numbers because if it did, then the denominator would be 0, which can't exist. Okay? What do you guys think? Are the pre-calculus students crazy?
Yes.
A little bit. Okay, that's okay. I love them dearly. They were all my students last year. Okay, let's do another one. P of x equals x minus 2 over 3 minus 1 over 3x. So, P of x equals x minus 2 over 3 minus 1 over 3x. So here is the awesome thing about these kinds of problems. The awesome thing is we can ignore everything except denominators that have x in them, okay? So the only piece of this whole lovely looking equation that we have to focus on is this, the 3x. And what do we do with it again? What did we do in the last one? Set it equal to 0. So 3 times x equals 0. Well, how do we get x by itself? Divide by 3. So x, can x equal 0, or what's the last piece that I have to put in here? X does not equal 0. All right, how are we doing on questions? Okay, we're good? Yes, Lorenzo. That's it, nothing else. Yes, true, good. Let's do one more. Last one, because you're going to run into this. So let's do h of x equals 3x plus 9. So remember, you only have to worry about this domain stuff if you have a denominator with a variable in it. Okay, so do we in this problem have a denominator with a variable in it? No. So what do we say here? What do we think? Thane?
If you divide the x plus the hx to the other side, since it's
Don't overcomplicate. Do we have a denominator here?
no.
No. When that's the case, the domain is all real numbers. That is the answer.
Can you put ARN?
A-R-N. Oh, A-R-N. Yes, you can put A-R-N for short. Brandon! What? Are there any denominators in this problem? No. So anytime there are no denominators, you can put that. All right, do we have any last questions? Okay. That's a no question. So your homework is page 119, numbers 4 through 32, multiples of 4. Everybody send us off from a really easy lesson. Yay!